Friends, there's a concept in quantum physics called superposition, which states that until a quantum particle is observed, it exists in all possible states at once. This means that a quantum particle can be everywhere in every form, at the same time. To explain this further, let's take Schrödinger's cat experiment. Superposition means that the cat in the box is both alive and dead at the same time, until the box is open and observed. Now, if we apply this logic to ourselves, it would mean that as humans, made of quantum particles, we too should exist in a superposition. We should be both alive and dead at the same time, and present everywhere. But if this is true, then what does it mean? Are you and I just existing because there is someone constantly observing us? Someone whose observation collapses the quantum state of the universe into a single reality where we exist. It sounds crazy, right? But if this is true, who is this ultimate observer? To answer that, a research paper on quantum superposition was published on January 3, 2013, suggesting that the black hole in space is the ultimate observer. It states that the black hole is the one that collapses the quantum state of the universe into a single reality where humans, like us, exist. So, how is this possible? Let's find out in today's episode. During a seminar at a university, physicist Wheeler was asked about the reality of the universe, and he drew a diagram on the board. At the top left, he represented the Big Bang, the creation of the universe, where everything was uncertain, and all quantum possibilities existed. On the top right, he drew an eye, showing that while the universe was forming from the left, there was an observer on the right collapsing all uncertainties into a single reality. This process is known as decoherence, where an observer's presence collapses a quantum state into one reality. To explain this more clearly, let's revisit Schrödinger's cat experiment. The cat is both alive and dead, trapped in superposition until someone observes it. Now, consider, why don't we, humans, exist in superposition like that? Or why doesn't the Earth or the entire universe exist in superposition? For a long time, researchers have been exploring this, and recently, a team from the University of Chicago, led by physicist Daniel Sun, found that in order to collapse the quantum state of particles in the universe, all that's needed is the event horizon of a black hole. Physicist Gautam Satish Chandra explained that black holes in space act like an eye that continuously observes the universe, collapsing the superposition of all quantum states into a single reality. To understand this, let's consider the behavior of quantum particles. For example, in the famous double-slit experiment, when a photon is fired, it creates an interference pattern on a screen. But when an observer is introduced, this superposition collapses, and we only see two distinct lines indicating the particle nature of the photon. Physicist Gautam Satish Chandra explained that black holes in space act like an eye that continuously observes the universe, collapsing the superposition of all quantum states into a single reality. To understand this, let's consider the behavior of quantum particles. For example, in the famous double-slit experiment, when a photon is fired, it creates an interference pattern on a screen. But when an observer is introduced, this superposition collapses, and we only see two distinct lines indicating the particle nature of the photon. Now, a recent 2021 study by Satish Chandra and Daniel Sun's team found that it's not necessary for an observer to be physically present near the experiment. The collapse of superposition can happen if the observer is light years away, observing from another galaxy, and it will still affect the quantum state of the photon. Imagine this via Orion. I am performing a double-slit experiment in my studio. Without an observer, I get the interference pattern, showing the wave nature of the photon. But what if there's an alien named Bob in another galaxy, observing my experiment through a powerful telescope? Would his observation collapse the superposition of the photon and affect my experiment? The interesting thing is, because Bob is light years away, his observation of my experiment from the past, before the photon was even emitted, would still affect the results. It doesn't matter how far Bob is or when he observes, it will still collapse the superposition of the photon into a single reality. Now, let's take this even further. What if Bob is observing my experiment from inside a black hole? We know that the event horizon of a black hole is a one-way ticket. Light can go in, but it can't escape. If Bob is inside the black hole's event horizon, the information from the experiment would never reach him. So, What happens if his observation is lost inside the black hole? Would our experiment remain unaffected? Here's the paradox. Quantum physics suggests that Bob's observation, even if he's inside a black hole, would still collapse the superposition and affect the experiment. This creates a contradiction with Einstein's theory of relativity, which states that no information can escape from a black hole. Yet, quantum mechanics still says that the observation collapses the superposition. In 2016, physicists Stephen Hawking and Malcolm Perry published a paper stating that before a quantum particle crosses the event horizon of a black hole, low-energy radiation around the event horizon can record the information of the particle. These low-energy radiations are called the soft hair of the black hole, which means that information is not destroyed in a black hole. This also helps solve the information paradox. Because these radiations act as an observer, they record the quantum state of the particle. This means that the quantum particle will collapse its superposition into a single reality. So, the bottom line is, our reality, as we see it, is created by the black holes in the universe, which collapse quantum superpositions into a single reality where we exist. And interestingly, event horizons aren't just found around black holes. As the universe expands, the same principle applies. We have our own observable universe, a boundary that separates what we can see from the rest of the universe. The universe beyond this observable limit acts like an observer, collapsing the superposition of all quantum particles into a single reality. So, in conclusion, many quantum physicists believe that gravity plays a role in collapsing superposition too. If the universe weren't expanding, black holes wouldn't exist, and everything might remain in superposition. In simpler terms, everything could exist everywhere, all at once, just like in the movie Everything Everywhere All at Once, but this is just a thought experiment for now. To prove this, we'd need to conduct experiments inside the event horizon of a black hole, which, with today's technology, seems impossible. But ultimately, the reason we exist isn't because logic says so, it's because something, somewhere, is constantly observing us, and this observation collapses quantum states into reality. This quote isn't from an American scientist, it's from their team. I hope you found today's video fascinating and that it gave you a new perspective on the universe. If you did, don't forget to like this video. I'll see you soon with another interesting one. Until then, goodbye.